All right, and recording just started. So welcome to week 3, Monday, August 23rd. You guys have a good weekend? Going good so far? All right. So quick recap on a couple of things from last week, and then let's get rolling on this week. So you guys remember back on Friday, you took a trigonometry vectors quiz. Now, I've graded those. You can find your grades in the grade book. The average grade was about 90%. Some just a little less, some a little more. So that was really awesome. Yeah. Hang on. Okay. All right. Now, there were a handful of students who like totally bombed that quiz, got like a 30% on it. If that is you, then I'd hate for you to start off the semester with a grade that would be extremely hard to recover from. So when I eventually get these back to you guys, if you find out ones you missed and then handwrite your work and turn that back into me and show me your work for the correct answers, then I'll give you partial credit. All right, another note about those quizzes is that I know we're in a quarantine situation, you got pandemic and whatnot going on. I've got 24 makeups to do. So before I can hand this out, you know, this makeup. So it might be a while before this gets back to you. Not because I haven't graded it, I have, you see your grade, but you just make this up. I'm thinking about that too, thinking, this does not really seem like a sustainable system. So what I'm thinking is, probably for the next quiz, what I have in mind is to create a take-home quiz. That's actually what I did all last year. I just made a bunch of take-home quizzes. There's some advantages to something like that. Now, I might have to make them a little bit tougher. You have to use a little bit more of your creativity, which is actually really good for an AP class, right? Because you guys are supposed to be able to think independently and creatively. And another advantage of something like this is that we'll have a whole extra school day to just do more practice. So that's one thing. We'll try this out, and if it works, then I might just keep doing that. All right. This week, we're getting into kinematic motion. This is actually going to take us a few weeks, 3 weeks. This is the first official unit in the book in AP Physics 1. So this is going to be both linear motion and projectile motion. We'll start with linear motion, just back, forth, up, down, right, left, just straight lines. Right. It can go back and forth, right, or up and down. Okay. And then we'll eventually get a projectile. So you guys know projectile. Take baseball, throw it at an angle, goes through, make it like a parabola shape. Right? So talk about that. Right. When we get to projectiles, all this trigonometry stuff is going to come back. Right? So stay tuned. I want to kick off this topic with what you guys did do today, which is car and ramp lab. About to talk about that. Now, sometimes I'll give you some notes so you know how the physics works, and then you can go back to the lab and figure out something for the lab. Right? Sometimes what I like to do is actually, before I tell you how any of the physics work, just throw you a bunch of materials and you can go back there and get your hands on the lab equipment. You're like, okay, let's feel what this mass is. You know, breaking out the meter stick and measuring the distances or protractor name. Right, so get your hands on the equipment, you get to think about how you think these variables work, what the relationships might be to each other, and then I'll come back and give you guys the notes after the fact. So that's how we're going to do this one. You guys get to explore first and see what you can figure out. Well, I've got Wednesday, we'll start, we'll actually probably start these tomorrow. How the time's been working on this lab is, you guys have had, or my earlier classes, they've had time during this Monday to get all their data, and then maybe start on some of the graphs, and then tomorrow we'll put back together the class, get all the graphs, and then after that I'll start you guys off with the notes for linear motion. Okay. Materials, if you want to look ahead a little bit, before you guys left for the weekend, I actually gave you guys one page already. Looks like this. There's a bunch of linear motion questions, like mathy looking questions, and on the other side there's some conceptual type questions. Hopefully you guys have at least read these by now. Started thinking about them. Of course, we'll go over these in the coming days. Okay. There's you guys got some questions from your textbook that I do have printed out. I'm going to give you guys probably tomorrow. Just want you guys to mostly focus on the lab today. But if you wanted to peek at those tonight, then they have been uploaded to Google Classroom this weekend. And also, since you guys are AP, there's a progress check that's going to be due in a couple of weeks, but it's actually been open for a while. I went and checked. It looks like some of you guys have already started to dig in there and start to answer the questions, which is really awesome. You're getting a head start. You're already thinking about this. You can go back and change your answers if something you learn in class, like, oh, hey, actually this works like this way or that way. Okay. All right. You guys stay with where we're going here? You guys good so far? Okay. There was actually one last thing I want to recap from last week. Things, actually a couple things. Right. You guys remember that gear you guys did the Geneva Drive, right? Right. I think was someone here who was saying like, oh, that's probably inside a clock. Yeah. I went right up on it. Yeah, you're absolutely right. That actually that's where it comes from. Why it's called a Geneva Drive, right? Like Geneva, Switzerland. Right? So good call there. And also, you guys remember I asked you guys this really hard dimensional analysis question has to do with how much land would you have to cover it by solar panels to meet energy demand? Okay. So this is the answer to that question. How many guys went and solved it? How many guys went and solved that? Okay. Well, here's what I gave you. There's the setup. Here's how you solve it. There's the answer. This is being recorded, so I'm going to throw this on Google Classroom. If you're really curious, then please do go check out the video and work through them. Yeah, even better, see if you can get it on your own and use this to check your answers. Right. Oh, yeah.
Sorry, you want me to make up my quiz real fast?
Yeah. I can get that to you. Let's see.
Yes. Thank you.
Yeah. All right. So, you guys ready for a lot of stuff? This gives you guys a lot of page. You have it clipped to the front of your desk. You guys see in the front of your desk, you have a full page. It's one of these full pages. You guys see one that looks like this? Oh, yep. Okay. Hang tight. I'll get to one in a few minutes, right? Okay, should look like this. Now, okay. First of all, what's going on with this, and then we'll okay. So, how many guys roll Hot Wheels cars down inclines? You guys can glance back to the lab stations. You guys see some inclines going down there. There's a bunch of Hot Wheels cars. There's some lab weights. A bunch of stuff to be able to answer questions for kids. All right, so what I want to know, and actually before I even ask the question, I should tell you guys that AP encourages AP teachers to create labs that are pretty open-ended. Not every single lab necessarily, not this one, but in the future, I might sometimes just throw you some equipment and say, like, ask your own question, or go figure something out, or set up your own experiment. And sometimes we'll have different groups come up with different ideas how to do something. Now, since this is one of the first labs we're doing, I'll keep this like pretty much like by the book, and we'll just follow on here. So this one will be a little bit more formulaic, but actually this is a pretty good one to start with. So I want to know, what is the relationship among mass, distance, and time for a toy car rolling down the incline? Right? Mass, distance, and time. You guys know those? Right. Now, if you have a really well-designed experiment, then how many independent variables should you have? Yeah, just one at a time, and then like one variable that's dependent on that, and then everything else you want to leave controlled, right? Well, if you go around counting the variables, right? Well, I've already got 3 here that I'm trying to juggle. You may notice there's also an angle there that could potentially be a variable. Now we'll leave that fixed, so that'll be one to control. But if you change one of these variables and then see how does it affect another one, well, one of these also has to be controlled. Would that make sense? Right? See, if I change the mass of the car to make it heavier, maybe that could affect how much time it takes to get to the bottom. If I change the distance, that probably also affects the time. But do I want to change both of those at the same time? No, now I'm really mixing and matching a bunch of stuff. Now I have something that looks really messy. So what I would hope you could figure out yourself is that we actually have to split this into 2 separate experiments. Okay. Now, you guys are either going to be in a team that's doing experiment 1 or experiment 2. Okay, so you're going to be either gathering this data or this data. We'll come back together as a class, and then tomorrow, when you guys come in class, first thing, we'll put all the graphs together. So you'll be able to get some graphs based on your own data, but then not the other ones that you don't have the data for. Okay. So experiment 1 is going to be independent variable, could be mass. So you guys can change out the mass of the car. And the way you can do that is have some lab weights and some tape back there. Do you guys think you can tape some lab weights to the car? I bet you guys can figure that out, right? There's also one scale. Well, it's a triple balance beam. You guys see the triple balance beam in the middle of the room back there? It's on that little table. Okay. So we're kind of limited on resources. I do encourage you guys to go back and try that out. That's a good skill to have, be able to use a triple bounce beam, be able to read that. If it's, I know we got like quarantine situation and a really packed house here and not very much room and stuff. So if you can't access that or you're having a lot of trouble accessing the triple bounce beam, here's a shortcut you can do. One Hot Wheels car is very close to 35 grams. Okay? Some a little less, some a little more. Okay? If you really can't access the scale, then you have to just use 35 grams for a blank car, or maybe you add on the weights after that if you're varying the mass. That's right. Okay? So yeah, go ahead.
Do you want to use our composition?
Okay, yeah, there's no, because I did tell you guys to, if you want to keep a notebook, if you write your write-up in a notebook and turn that in, then that's fine. What's probably easier to do is just to use the page that I gave you, and there's still stuff I want to talk about that. The paper, you can just turn this in, and then I'll give it back to you, and then you can just put this together and create your own notebook from that. Right, take it through. Right. So it's up to you. You can go either way. Right. But all right, so back to experiment one. Okay, so here you'd be controlling the distance. So if you're changing out the mass of the car, you're going to keep the distance the same every single time, right? Same distance, right? And also the angle, right? Like that. All right. Let's do some hypothesizing for changing the mass. How does that affect the time? Okay. So I'm going to throw out 3 hypotheses, and I'm going to see show hands what you guys think. So the first possibility is the heavier I make the car, maybe it makes the car reach the bottom faster. That's to say, it decreases the time interval. Second possibility is I increase the mass of the car, maybe the car goes more slowly. It takes more time to reach the bottom. And third possibility is maybe the time to reach the bottom has nothing to do with mass at all. Okay? So let's see, show hands. How many guys think that if I put on more mass, it's going to reach the bottom faster? It's going to decrease the time. Okay, so see some hands there. How many guys think if you increase the mass of the car, it's going to more slowly? It's going to take more time to reach the bottom. And who says it probably makes no difference at all? I change mass and it takes the same time to reach the bottom. Anybody see that? Okay, so got one hypothesizer for that candidate. All right, so that'll be the first experiment. All right, second experiment, again, you're either doing this or this within your group, is changing the distance and seeing how does that affect time. And if you do this one, of course, you're controlling mass, so just use the same mass bar over and over again. Okay? You know what I don't have explicitly listed as a control? Yeah, do you want to use the same car over and over again with the same wheels and same axles? Yeah, that could be something you want to also control for, right? You want to control for, ideally, even like the temperature of the room and all that, although that's a little silly in this case, but you're controlling everything except for these things. Okay. So as you increase the distance, I mean, you guys can all figure out it's going to take more time for the car to roll more distance, right? Okay. So I'm going to couch this hypothesis a little bit different way. Let's say if you double the distance, what would that do to the time? So here are your 3 possibilities. If you double the distance, say from 100 to 200 centimeters, if you double the distance, is that going to also double the amount of time it takes the car to reach the bottom? Or is it going to more than double the time? Like if I do double the distance, does the time interval more than double? Or does it increase, but it doesn't quite double? Okay. Let me see what you guys think. So hypothesis time. How many guys think if you double the distance, that the time will pretty nearly also double? Like double. Who thinks that? Okay. Who thinks if you double the distance, that it's going to take more than twice the time to reach the bottom? And who says if you double the distance, time will increase, but not quite double? Ooh, all right. Let's answer that one. All right. So how you guys are thinking a bit about this? I have some other things I want to mention. The lab page you guys have, there's technically 2 slightly different versions. Particularly, it's got trials. Now this page, you got different distances you can have all the way down, but look at our mass for my particular page. See all these hash marks? So the idea here is that you'd be controlling for the mass, so you're just using the same mass all the way down. Okay. Now if you don't have the page that looks like this, you have one that has hash marks in the other column, right? Like the distance column, so you'd be controlling the distance and changing out the mass. So it's going to be one or the other, right? Okay. Then look at this. Once you take 3 times and take an average, right? Now, this is, when you guys get the AP exam in May, you're going to be given an experimental design question. It's one of your FRQs. And this point right here, that's trying to do 3 and take an average, that's going to take you at 1 AP point. Like, well, it's just a question that always comes up. Okay. Now, question is, why? Why should you do 3 trials and take an average? Give you guys a couple of possibilities. Is it because doing 3 times for the exact same scenario, right? Same mass and distance, right? It's doing an average. Will that decrease random error, or will that reduce systematic error? How many guys think that that is meant to target random error? Random error. And who thinks systematic? Systematic. Okay. So random would be like this would be a stopwatch issue, right? Random is sometimes you're a little early on the stopwatch, sometimes you're a little late. What if you do electric files that kind of evens out? Actually, is that what that sounds like? What you do? Yeah, that's what it's supposed to address. It's supposed to address random error. Systematic is more like if you're always early or you're always late with the stopwatch. But then if you do 3 and it's average, it doesn't really address that, right? So I think that. Last column says take the square of the time. That, yeah, I won't tell you guys very much about that. Let's see if you guys can figure out what's wrong with that. All right, then you got some graphs. Now, you guys might have a few spare minutes at the end of class today where you can start putting these together. Now, you yourself and your team can't put all 3 graphs together because you won't have all the data. See how some of these say, like, borrow data to complete? Okay. That's why first thing tomorrow when you guys come in, I'll take some volunteers if you feel pretty good about your data. I'll plug it into an Excel spreadsheet, so Excel will create a perfect graph, and then whatever graph you don't have, you can just copy that one. Okay, let's go. All right, then here's our goal to figure out how does distance at some number of degrees, how's that affected by those other variables. Okay. Oh, speaking of degrees, okay, that's something we're also controlling for, right? See at the top says ramp angle is some blank degrees, so many degrees. This way I should have specified to the horizontal. Okay. Anytime you're specifying an angle, I'm going to say, is it to the horizontal or to the vertical? That's usually what you measure with respect to, like one or the other. Right. So probably about 5 or 10 degrees, maybe somewhere in there. Okay. Okay. And last thing I got to mention before you guys take off is there it goes. Okay. On the back of this page, yes, here it says has these 5 questions. Well, question, measuring tools, data gathering procedure, analysis, and conclusion. Okay. Probably every lab you guys do, I'm gonna have you guys do some write-up that looks like this. So again, if you have some spare time, like the last 2 minutes of class, then see how much of this you can knock out in class while you're here in school. Okay. So you have 1 of 2 questions. Either you're figuring out what's the relationship between mass and rolling time or distance and rolling time. Right? It's going to be one of those 2 questions depending on what you have. Okay. The reason that I did have these same questions, like the same format for everybody, is that when you guys get that FRQ in May, and you'll get an experimental design FRQ. I've read so many AP FRQs. I know what their thought process is. I know how they award points, and it's very similar to this exact rubric. Right? There's certain things that AP is always looking for. Okay? They're going to want to know what measuring tools did you use. So, do I use a triple balance beam? Do I use a meter stick? There might be a couple of other tools. Pay real close attention. Think about what you're using to measure. Okay. Then there's going to be a whole section where you have to say, how did I go about gathering my data? That's what this is for. So it says in parentheses, how to measure what variables using aforementioned tools. So I used the triple balance beam to measure, use the triple balance beam to measure the mass of the car. Use the meter stick to measure rolling distance. Blah, blah, blah. Okay. If there's some independent variable, then say like, oh, I'm going to go back and change the mass of the car, or I'm going to change the mass, or the starting distance, something like that. Okay. Once you communicate how you're gathering that data with these measuring tools, okay, next section is how to analyze the data. Now, there's different categories of labs, like different thought processes that you would need, so depending on what kind of lab. There are some labs we're going to do in the future where you're going to know the equations and you're going to try to figure something out. Like, for example, this pin has a spring in it. You guys see a spring? You think that different springs have different stiffnesses associated with them? Some springs are really stiff, some are not so much. You think there's equations that probably go with those? Right? You think maybe if I unscrew this, let it go, and I measure how high it springs up to? No. So I could go back and I could calculate how stiff the spring was in principle. Right? So that'll be something in the future. And that's one type of lab. Now this is not that category lab. This is the category of lab of we're going to say that we're cavemen. We don't know how physics works. We got some materials and we're going to find out. So say in parentheses says some property of a graph maybe, or some use of an equation. Okay. Well, the equation is not going to be very useful because we don't know the equations. Okay. But hey, you guys saw some graphs that I gave you guys, right? Did you guys start on this? Okay. So, I wonder what variables we put on which axes, and then maybe what property of what graph is going to tell you what. Is going to be some slope of some graph that tells you some property that could answer your question, okay, something like that. And then finally, conclusion, what's the answer to your question? Okay. So how is mass related to rolling time? How is distance related to rolling time? Okay. Remember those hypotheses that I threw out? You guys were raising your hands about which one you thought it was? Okay. Well, somebody's going to be right, and then that could be your conclusion. Right? Who's got any questions? Any questions so far? All right. So we told you guys how this has been going all day today is that students have had time to gather all their data. You can make the graphs that you have on your page, put the other ones together first thing tomorrow. Okay. Oh, here's what else we're doing tomorrow. I have a rubric that I'm going to have you guys grade yourself by. So have these questions answered by, well, about 5 or 10 minutes in the class tomorrow. Okay. Then I'll pull out that rubric and we'll go, it's AP style. So it's the kinds of things that AP would be looking for. We'll do a checklist like, do you have this? Do you have this? Do you have this? You can grade yourselves. And then if you do really awesome, then that means you know what AP is looking for. And if not, then it's not going to count against your grade, your class grade, but you'll know like, oh, okay, I did not mention this detail, but I know AP is looking for it now. Okay? You guys get that in? Okay. You guys ready to go get your stuff? All right, so everybody back there, we'll walk back and help you guys out.